When it comes to the trig identities on the ACT, you're most often going to encounter questions that test you on your knowledge of SOHCAHTOA, or sine, cosine, and tangent. Sometimes, however, your knowledge of other trig identities will be tested. So in this video, we're going to go over a few other things that you may need to know in order to maximize your score on the ACT. We're going to start with tangent. I know that we already know tangent as the TOA part of SOHCAHTOA, meaning opposite over adjacent. However, tangent may also be rewritten as sine of theta over cosine of theta. It's the exact same thing, it's just another way of looking at it. Cosecant is the reciprocal of sine. So the cosecant of theta is 1 over the sine of theta. So instead of it being opposite over hypotenuse, it's hypotenuse over opposite. Secant, likewise, is the reciprocal of cosine. So the secant of theta is 1 over the cosine of theta, or hypotenuse over adjacent. And finally, there's cotangent. And as you might have guessed, cotangent is the reciprocal of tangent. So cotangent of theta equals 1 over tangent of theta, or it's cosine of theta over sine of theta, or it's adjacent over opposite. One other thing that you may come across on some versions of the ACT is the Pythagorean identity, which is based off the unit circle. Anyway, it's sine squared theta plus cosine squared theta equals 1. Of course, that can be rewritten to isolate cosine squared theta or sine squared theta. Let's do just a couple of practice problems to practice these other trig identities. In the diagram above, what is the secant of b? So secant is 1 over the cosine. So instead of adjacent over hypotenuse, we have hypotenuse over adjacent. So the hypotenuse is z, and adjacent to b is x. So secant of b is z over x. In the above diagram, if cosecant of a is 13/12 and cosecant of b is 13/5, what is cotangent of a? So I'm going to redraw this diagram really briefly. And we're going to start with the cosecant of a. So cosecant is hypotenuse over opposite. Again, it's the reciprocal of sine. So the hypotenuse must then be 13, and opposite has to be 12. Moving on, we'll look at the cosecant of b. We already know that the hypotenuse is 13, so then opposite, of course, has to be 5. So now we want to find the cotangent of a. Now that we have the diagram, the cotangent of a, instead of being opposite over adjacent, it's going to be adjacent over opposite. So the cotangent of a is going to be 5/12. Last, let's simplify the following expression. In parentheses, 1 minus cosine squared theta, close parentheses, squared, over sine squared of theta, plus, parentheses, 1 minus sine squared theta, close parentheses, squared, over cosine squared theta. So let's look at the first part of this. So 1 minus cosine squared theta, that is simply just equal to the sine squared of theta, if we use the Pythagorean identity. So we have sine squared theta, and then that is squared, over sine squared theta. The second part of the expression looks pretty much the same, except we have 1 minus sine squared theta now, so that's going to simplify to cosine squared theta. And then that's squared as well, over cosine squared theta. We can simplify that further, because we have sine squared theta times sine squared theta over sine squared theta, so that's just going to leave us with, in the first part, sine squared theta. Then in the second part, it's the same thing, so we'll be left with cosine squared theta. And of course, that is the Pythagorean identity, sine squared theta plus cosine squared theta equals 1. So that expression equals 1.